Number 6, Becky spent 2/3 of her piano practice time on her recital piece. If she spent 25 minutes on other pieces, how many hours did Becky spend practicing in all? Now, before we get into this problem, I want you to pay attention to this 2/3 piece. Now, 2/3 is a fraction, or it's a proportion. 2/3 and 1/3 plus 1/3 equals 1 whole. Okay, so 2/3 plus 1/3 equals 1 whole. So 3/3 equals 1. It shows that she practiced 2/3 of her time on her recital piece, on that recital piece. And the other portion of time has to be 1/3. And this is on other pieces. We know that the 2/3 was spent on the recital time and the 1/3 was spent on other pieces. And it gives us the quantity of time, 25 minutes. So if 1/3 was 25 minutes, what must 2/3 be? It would just be doubled, right? Or 2 times that, be 50 minutes. Another way you can look at that to draw another diagram or draw a picture for this word problem is to draw a rectangle. You could do a pie graph. And so this is broken up into thirds. And let's just say this portion is the 2/3 and this here is, well, yeah, 2/3. We know that this 1/3 portion is 25, but what would this 2/3 portion be? 50, right? Just by addition. So 50 plus 25 is 75. So that actually is the answer to our question, but we still need to come up with an equation and let's solve it. I just want to draw this for you because this could be your picture when I tell you about tips in solving word problems. Draw this picture out and you can find your answer. So, okay, so how many hours did Becky spend practicing? That's in total. So we'll assign our variable, let P equals total practice time. Total practice time. And we know that 2/3 of her practice time was devoted to her recital. So we can say let 2/3 P equal recital practice time. So now we're ready to set up our equation. So our total practice time equals our recital time, which was 2/3 of 2/3 P, plus the other practice time, which was 25 minutes. So that's our equation. Now we need to solve for P. So a couple things we can do here. We need to get P all by itself, but I need to join these two like terms together. So I'm going to subtract 2/3 P from this side. And what I do to one side, I need to do to the other. So I'm going to rewrite all of this. Minus 2/3 P plus this P equals 25. Now we have negative 2/3 P plus 1 P, right? Because there's that imaginary 1. And if you guys remember, we can pull out a P from here using the distributive property, kind of in reverse order. So we have a negative 2/3 plus 1. Everyone see that? Like terms here. We're going to subtract a positive from a negative. 1 minus 2/3 is 1/3. P equals 25. And if we need to get P all by itself, so we need to get rid of 1/3. How do we get rid of 1/3? Just to be able to cancel it out, we multiply by 3 or 3 over 1. I'll just put 3 over 1. 3 or 3 over 1, both work. If those cancel, we're left with P. 25 times 3 is 75. So, and it matches up with our little visual up here. So 75 minutes of practice also equals 1 1/4 hours. So either one works. So remember, you need an answer, you need to solve for P, and then you also need an equation. So our equation was right there. P equals 2/3 P plus 25. Number 7, David worked in the library on Friday and Saturday, 2 days. He worked a total of 7 3/4 hours during those 2 days. We got a total, so that signifies that equal sign, right? 7 3/4 hours total. If he worked 4.5 hours on Friday, how many hours did he work on Saturday? Let's circle our question. How many hours did he work Saturday? And we're going to let our variable that we're going to assign answer this question. Let's call it hours. So let H equals hours worked Saturday. Nope, I'm going to change it to S. Let S equals hours, or let S equal hours worked Saturday. Again, feel free to assign any variable you want. I just usually like to assign the variable with the first letter of the word. So let's start writing out our equation. So we know we have a total, 7 3/4 hours total. That's going to go to the right of our equal sign because it's the total. Now we have 4.5 hours for Friday. We would need to find out what Saturday hours are. So we're going to add 4 1/4 plus the S. So we have, or S plus 4 1/4. So that is going to be our equation. Now let's solve. We need to get S all by itself. So let's subtract 4 1/4 from this side. That cancels out. And what we do to one side, we do to the other. Now we're left with S equals 3 minus 1 is 2. And the denominator stays the same. 7 minus 4 is 3. 3 2/4 can be reduced to 3 1/2. So S equals 3 1/2 hours worked on Saturday. So you need that equation and you need this answer. Number 8, the coach wants to spend 3/8 of basketball time on defense. So 3/8 on defense. He plans to spend 45 minutes on this. So 3/8 is that 45 minutes. How many hours will the team spend practicing total? How many hours will the team spend practicing? Let's assign a variable. Let P equal practice time. Total practice time. Again, always look at your question. That's how you know what to assign, how to assign your variable. How many hours will the team spend practicing? Let P equal the time the team spends practicing. Before we write up an equation, let's do another visual here on this 3/8. So I'm going to draw a diagram. I'm going to try to draw it well. And we know that 3/8 of the basketball time was spent on defense. So I'm going to, let's see, try to my best to 1 2 3 4 5 6 7 8. Okay, this box is broken up into eighths. Okay, So those 3 are spent on defense. Because 3 3/8 of the time is spent on defense. Another thing we know is that this time that coach wants to devote to this 3/8 of the practice is 45 minutes. That also means then that the next 3, like the next 3 parts of this fraction or this visual is also going to be 45 minutes. What would that make these two right here? 30, right? And just for the sake of, let me just put, this would be the 3/8, and the rest would be what? Would be 5/8. Hopefully you guys like my cool visual. Cool, eh? But anyway, so total hours practicing, I'm just going to go ahead and add those numbers up. So 45 and 45 is 90 plus your 30 here. That gives you 120. So 120 minutes practice or 2 hours. 2 hours. So let's just check that with our equation. We still need our equation to check that out. So hours practice are, P equal the total practice time. Remember, our total can go to the right side of our equal sign. Actually, I'm going to write this up a different way. Because if you look at this statement, 3/8 of practice time was 45 minutes. So let's read that again. 3/8 of basketball practice time is 45 minutes. So watch this. 3/8 of, meaning multiplication, practice time is 45 minutes. I'm sorry. This should be P, not X. 3/8 of practice time is 45 minutes. You guys see that? 3/8 of basketball time. No, I'm sorry, I'm saying that went wrong. 3/8 of basically practice on defense is 45 minutes. So this is going to be your equation. It's kind of like a word phrase. 3/8 of practice time is 45 minutes. 3/8 of practice time is 45 minutes. So let's use this equation and see if we come up with 2 hours. So we need to get P all by itself. We need to take the inverse in order to cancel, right? We're left with P. What we do to one side, we do to the other. You can either multiply straight across, 45 times 8, or you can recognize here that you can cross cancel. So 3 goes into 45 15 times, 3 goes into itself once, 15 times 8 is 120, and those check out. So 120 minutes or 2 hours. And again, you will use this equation here, 3/8 P equals 45. Boy, that looks really messy and sloppy. Sorry about that. So for number 9, I'm going to go ahead and let you guys kind of figure this out. I'm going to lead you through it, and then maybe Mr. Anderson can help you finish it. But if you need more help, or maybe I'll lead you, well, we'll see. Okay, so Mrs. B.A.I. spent twice as much money as Alice on their shopping trip. So here's an important word, twice. So this lady, Mrs. B.A., spent twice as much money as Alice. She's a big spender on their shopping trip. If they spent a total of $386.16, how much did each spend? So we got a total here. And we know that Mrs. B spent twice as much as Alice. So let's let Alice Oops, you guys can't see that. Let X equal what Alice spent. And if Mrs. Bai spent twice, what would she spend? So Mrs. Bai would need to spend what? Twice as much. So Alice spent X. This Bai lady spent 2X. Okay? Because she spent twice as much. So you're going to add those two together to get your total. So we got Alice spending X. We got Mrs. Bai spending 2X. And then, so I did give you guys the equation. Let's see who can get the answer. And the answer is, how much did each spend? Now, when you solve and you get the answer for X, that answer will be what Alice spent. And then what you get for X, you double it and get what Mrs. Bai spent. Make sense? Okay, so go ahead and give that a try. Mr. Anderson, whoever gets these answers right first, you can give them one of those chocolates, those old chocolates that probably are all moldy from a couple weeks ago before Christmas break. Those winners can get one of those chocolates if they get those right. And I'll send you the answers on a text. Number 10. Mr. Jordan, Michael Jordan, just kidding, plans to leave the total of his savings to his 4 children. So there's the total, there's a number 4. If they are the same, wait, let me move this over a little bit. Long word problem. If they are all to receive the same, that's important, amount of inheritance, and the total savings that he has is $501,052.40, how much will each receive? Okay, so we have a total that they get to work with here. $501,052.40, and they're dividing it by 4 children. So let's look at our question here. I can move this over. How much will each receive? So let's what can our variable be? We'll just call it C for child. How much will each child receive? Let C equal how much each child receives. So, since we know that it's going to be divided by 4, we will choose 4C equals, again, I drew my equation a little funny. Should be closer that way. 4C equals $501,052.40. And let's solve for C. I'm going to write it over so it's not so far apart. Divide by 4 on both sides to get C all by itself. I will go ahead and let you students work on this problem. And Mr. Anderson, you can pick, the first one to get it right. That's, I'll send you the answer on a text, and you can give them a piece of candy from the cupboards, the old moldy candy from the cupboards from before Christmas break. Just kidding. I think it's still, it hasn't expired because they put so many preservatives in that candy that it lasts a year. All right, guys, that's number 10. So we're all done. I hope you guys are learning. If you need reinforcement here, go home and watch these problems again. And we'll see you tomorrow. Well, we won't see you, but we will work again together tomorrow. Take care. Bye. Bye.